it is time to talk about the fundamental theorem of arithmetic. Our learning objective in this tutorial is twofold. One is that we want to understand what exactly is this fundamental theorem of arithmetic, and the second is how exactly we can use it to find the HCF and LCM of two numbers. Okay? To begin with, let me explain in a very simple way that let's say there is a number, a composite number 630, okay, and then we divide that into its individual prime factors, okay. So first I divide that with 3, for example, because 3 is a prime number and we obtain 210. Then I take a number 2 and then I divide that, I obtain 105. Then you take the next step, divide with 5, you obtain 21. You take further, divide with 3, you get 7. And this is pretty much the way that you will obtain all the prime factors of this number, right? We have learned about this method in our earlier grades as well, that how do you break down a number into its prime factors, and all of these are my prime factors, right? So if I were to put it like this, that 630 is equal to, there is a 3, right? And there is 3 1 and 3 2. So it's 3 to the power 2 times 2 times 5 times 7, right? And now think about this. If I would simply change the sequence of the multiplication of these prime factors, would that change anything? No. This result would still be the same. It would be still 630, the original composite number. It doesn't matter whether I pick the sequence 1 or the sequence 2. This is also called a commutative property in multiplication, in which the order in which the numbers are multiplied doesn't matter. As long as we don't change the numbers, the net result of this product will still be the same. And that is exactly what we have here. Or in a simple English sentence, we can say that the fundamental theorem of arithmetic is that every composite number can be factorized as a product of certain prime numbers. Okay, these are the keywords. And such factorization is unique for that respective composite number, even though the order in which these numbers could appear in a multiplication could vary, it could change, right? And that is all about our fundamental theorem of arithmetic, right? Now, sometimes we have seen a mathematical representation of this sentence on the fundamental theorem of arithmetic. So let me write it this way. So let's say, instead of writing 630, I replace it with a very general number. Let's say that is x, okay? And each one of those prime factors, so it is 2 here. So let me say that this is my prime factor 1. This is 3 here. This is my prime factor 2. And so on. There could be n prime factors in this product, right? So let's say there are n different prime factors and we are multiplying them together. And there is an exponent part. That exponent part simply tells that how many times that prime factor will appear in this product. So this mathematical expression means the same thing what we have here in the words, that any composite number x could be written down as a product of its prime factors, and those prime factors are unique. The combination of these prime factors is unique to that number itself. That is the fundamental theorem of arithmetic. Now let's take a look at some examples to understand this theorem a little bit better, okay? So let's say we have been given 3 numbers, 29 times 35 plus 14, and our objective is that this number is a composite number, okay? So let's try to simplify this number. Let's say this is 29 times 35 can be broken down into 2 pieces, 7 times 5 plus 14 is 7 times 2. Let's simplify further. 7 comes out, inside the parenthesis will be 29 times 5 plus 2, which is 7 times 147. And when you break down this 147 into its prime factors, it will be 7 times 3 times 7 times 7. Or it is equal to 3 times 7 to the power 3, right? So what we have really obtained here is that this is a unique combination of these prime numbers that is equal to this original number that we begin with. So if we were to equate it to some mathematical form, that let's say this whole thing is equal to x, and this is equal to p1 to the power a and p2 to the power b, where p1 is 3, p2 is 7, and a is equal to 1 and b is equal to 3. And this expression indeed satisfies our fundamental theorem of arithmetic, Hence we say that x, the number here, is a composite number. Hence we say that this is a composite number. Now let's see that how we can use it to find the HCF and LCM of two numbers. So using the concept of that every number can be broken down into its prime factors, we obtain a definition of HCF and LCM. The HCF of two numbers is the product of the prime factors having the smallest power of each common prime factors between two numbers. Okay, and LCM is the product of the prime factors having the greatest power of each prime factor between two numbers. And these are the two key differences when we work on finding the LCM and the HCF. In HCF, we look for the common prime factors. In LCM, we look for each prime factor and we look for the greatest power versus the smallest power here. Okay. So let's take an example. I have two numbers here, 432 and 676. We are supposed to find the HCF and LCM of these two numbers. Okay. These both are composite numbers, so we should be able to break them down into their prime factors. Okay. So I will let you do the exercise of breaking them down into the prime factors, but I'll tell you the final result here. So this is 2 to the power 4 times 3 to the power 3. Okay, and 676 is equal to 2 to the power 2 times 13 to the power 2. Okay, now take a look at our definition. The HCF is that the product of the prime factors having the smallest power, right, of each common prime factor. Now, what is a common prime factor between these two numbers? We say that, yes, I see 2, so I will write 2 here. Okay, and then we have the smallest power is 2. So HCF is 2 to the power 2, and that's it. 3 is not common, 13 is not common, so we stop here. So this is my HCF, which is 4. We are done with that. Okay, now let's take a look at LCM. LCM is the product of the prime factors having the greatest power of each prime factor. Okay, so let's go one by one. First, I have a prime number 2. So LCM will be 2. And what's the greatest power? I see that the greatest is 4. So I'll take the 4 here. Times. Next prime number is 3. I'll take 3. The greatest power is 3 because there is no other 3 in these two numbers. So I will take this. Then I will take 13, and 13 has the power of 2. Right? So this is it. So this is my LCM of these two numbers. Not complicated at all, right? And we pretty much learned about the same fundamentals previously as well. So we take a pause here, and that is pretty much everything about the fundamental theorem of arithmetic. The real applications are using this theorem to prove some other theorems and also be able to find the HCF and LCM.